Hello everyone, good morning. I hope I'm audible as well as visible. Great, so good morning everyone and welcome again to our stream which is data analysis in 3 weeks. So we have been discussing about quite a good amount of topics, but today the topic is to start the data visualization, right? So we discussed yesterday about docx, PDF, and we also discussed about how we can do the data visualization. So today the topic is data visualization. So we'll be starting the discussion on data visualization. So what all different APIs are available within your Python library, and then how we're going to use it for our data analysis purpose. So we're going to be doing that. So today we'll be starting with Seaborn, guys. So that's our objective, and also I'll be telling you what is the difference between Seaborn and Matplotlib, and what are different inbuilt functions we have available in Seaborn. So I'll be discussing all of that today. Okay, so please stay tuned with us, guys. But again, welcome everyone. A very warm good morning to one and all present in our chat today. So we're starting with data analysis in 3 weeks. That's our playlist, and we're starting with Seaborn and Matplotlib data visualization today. Great. So guys, do let me know if I'm pretty much audible as well as visible to you. So just do let me know that if I'm pretty much audible as well as visible. Great. So let's quickly start, guys. Let's quickly start. Okay. So before starting, I'll just again, as always, I'll introduce myself. My name is Arpit Jain, and I'm a lead data scientist myself. I have almost 9 years of industry experience into multiple domains, be it manufacturing, be it telecommunication, finance. So a lot of multiple domains I've been working with. Okay. So you can definitely ask me any questions regarding any topic, if you have in anything regarding any of the domains or anything specific in terms of data science as well, right? So if you want to switch your career to data science, any specific thing. So guys, feel free to ask your questions, okay? It's pretty much a live session. And as always, I've always been promoting this. Talking to people also is an art, and trust me, asking a question is not easy, okay? It takes courage to ask questions. So if you're asking question, trust me, you have an X factor, right? And if you're not asking question, there could be two reasons. Either you're really smart and trying to, you're understanding everything. And the second is you're not smart, you're being actually dumb, and then you don't have that courage to ask the questions, okay? So either of the things is, if you are smart enough to understand, that's really a wonderful thing. But again, if you're trying to think that, somebody will make fool of you to ask question, don't do that, okay? So this is the right time to ask your questions, because otherwise you'll be in doubt in like forever, right? Great. So again, keeping everything aside, Hellfire, good morning. Vasant, good morning. Vasanta, good morning. And I have we have people also coming in. So guys, do let me know if there is anything. Okay. So we'll anyway take up that. But again, so just to give you a recap of whatever we have discussed so far, we have finished the basic data types. We have finished list, tuples, dictionaries. We have done some good exercises as well. And we were seeing data types, functions, lambda functions. We discussed about data types, text, CSVs, Excel file. We discussed about docx, PDF yesterday. So we saw the different complexities also involved in that, right? So guys, any questions, anything, please feel free to put up a question in the chat and I'll try to take that. But again, for now, let me just pull up the content slide. So which is again talking basically about my, just give me a minute. Let me just pull up this. So I'll pull up the Seaborn tutorial for you guys. So just give me a minute. Should put it here. I don't know why this is not popping up. Right, so it just came, just a minute. Right. I hope my screen is pretty much visible to everybody, right? Okay, so just to start with, as I said, today we are starting with data visualization. Okay, so that's a topic for today. But again, before proceeding, we have to first understand what is data visualization. And eventually I'll be also talking about in data visualization, what are different things are important, right? For example, as I said, Seaborn, what is Seaborn? Then what is Matplotlib? So how we take up these things, what is the difference in these, right? And what are these actually? So we'll be discussing on all of these, okay? So Akash, good morning. Thank you so much for joining us. Great. So Seaborn and Matplotlib, guys. So first of all, I'll just talk about data visualization a bit. So now you have data in front of you, right? What is a data? It's like a structured, collection of information. So like basic definition, okay? But again, what is the data? Think of it as an Excel file, for example. You have an Excel file, right? Spreadsheet. So that Excel file itself is a data for you, right? Likewise, once we load up the data, like for example, docx, we try to convert into some a mutational format in which we can perform some action, right? So that is my data. So now, once we have the data, there are two ways which we generally analyze the data. So we apply some statistics rules on top of it. We'll try to see, how the data dispersions are. So a lot of things which we do. And then we also try to analyze the data visually, right? So what are my hidden patterns available inside? So we try to plot some graphs. So there are some, a single variable graph or double variable graph. We have x-axis, y-axis, or we simply use one axis and then try to plot the count and something, or a frequency of something, or density of something. So likewise, whenever we try to analyze the data in forms of a graph, or by plotting the data in some or the other graph. Okay, there are multiple graphs. I'll talk about that, so don't worry about it. I'll talk about what all different graphs are available. But again, for now, if the data is getting kind of analyzed in a visual format by plotting the graphs, that is called as data analysis or data visualization. Okay, so this data visualization, the plotting of my graphs, basically in Python we have, again, we have 2-3 standard libraries which are very formally used for plotting of my graphs. Matplotlib being the standard one, the base of almost everything. So Matplotlib, okay, so Matplotlib is the standard base scale. Seaborn is a high-end API. It's a high-level API which is built on top of Matplotlib, leveraging the functionalities available in Matplotlib, and again on top of that, giving some extra additional benefits. Okay, so since ancient days, I won't say ancient days, since like long time, Matplotlib was always existing. Okay, now Seaborn was an extension, or Seaborn is like another high-level API which is built on top of Matplotlib library, leveraging the functionalities available within this, and then giving a high-end, again, some additional benefits on top of it. Okay, so now let's see what is Seaborn and what is Matplotlib. So what are different things that are available? Okay, so as I said, Seaborn is nothing but is a Python library providing you high-level API for visualizing the data using Python. Okay, so here we're trying to visualize the data using Python. So Seaborn is a high-level API which is giving me that visualization, the benefit on Python. So by using this Seaborn, this API, we can visualize the data on Python programming language. Okay, so this is what Seaborn is. So as I said, it is built on top of the Matplotlib library and also closely integrated to data structures from pandas. So now pandas, right? So pandas data frame. So pandas is again, it is very closely associated with pandas as a data structures, right? So once we have processed the data on pandas, it's very easier to plot the pandas data frame on Seaborn because it is very closely associated with pandas. Okay, so that's again one of the very good benefit of Seaborn we have. So now if we have to see the difference between Seaborn versus Matplotlib, it is again a very standard kind of conceptual question which is again asked sometimes in the interview, like what is the difference between Seaborn and Matplotlib? Why do we use Seaborn? Why can't we use why only, what is the benefit of using Seaborn over Matplotlib? So generally these kind of conceptual questions are also asked. So for example, here Seaborn is an extension of Matplotlib. Okay, so as I said, so Seaborn is not built from scratch. Seaborn is an extension of Matplotlib. Okay, and Matplotlib is fairly good for easy work but competent for hard work. Okay, for example, here if I have some fairly decent, not so complex kind of data. So for those easier kind of a data which can be even very easily been analyzed just by looking at the data, right? So those kind of data which is not so complex can be easily visualized using Matplotlib. But for more competent data, where more for hard data in terms of you have multiple variables, multiple columns, really hidden, a lot of complexities, some mixing data, so a lot of things are there, right? So for the hard work, this is where it's a bit competent. So Matplotlib is not fairly decent with some really complex graphs. Okay. Seaborn makes the hard work also simple. As I said, so Seaborn, it's comparatively easier to plot some complex graphs, like 2-3 axes, multiple variables in a single graph, and then changing the edges, changing the axis, a lot of things. So a lot of such functionalities, a lot of such freedom is available in Seaborn. Okay. And again, as I said, so Seaborn is well known to work with data frames like pandas and NumPy. Okay, so pandas and NumPy it is very much closely associated. So Seaborn is very much closely associated with the data frames, which is pandas and numpy. Okay, that is again giving it an upper edge comparatively to Matplotlib, because again here we have even the analysis, it's generally being performed on pandas and numpy, because again even we'll be having separate classes on pandas and numpy as well, but that is where we'll have the additional benefit of using that too. Okay. So what are my salient features here? So Seaborn features, it involves built-in themes. So for example here, the salient features involves my built-in themes. So we can change the theme. So we can change the lookout of my entire graph. So we can change the font, we can change the whole layout of my graph. Okay, so we have certain themes available for my graph. That is a salient feature of Seaborn. We can make it more appealing. Okay. And also it is very much good for univariate and the bivariate analysis. So now what is univariate and the bivariate? Okay, still little technical term, but it's very simple to understand. Uni means one, right? Bi means two, right? Variate, simple variable. Bivariate is variable, right? So univariate, one variable. Bivariate, two variable. Okay, so univariate means one variable analysis. So how can you plot a graph of one variable? I mean, you need some x and y axis, right? So how can you plot a graph of one variable? Very good question. So now in univariate analysis, a lot of things which we do, right? So we try to see the dispersion. So we can always see the dispersion, right? So how the data is getting distributed. What is the dispersion of my data? What is the data spread? How the data is being spread out? Like we plot a histogram kind of a thing, or a KDE plot. Like we try to see the run chart of my data. That is again very much possible. We can also see, for example, if this univariate is my say categorical column, for example, it's a class. So we can also see the count of my variables. So suppose I have a variable called as gender, and I have say male and female there, right? So generally, so in that male, female, and then we have what? So we can count the number of such population. So say whatever the split is, and then also we can have another classes such as say rating, good, bad, average, for example, right? So we have say good as say 80. Bad as say 20 and average as say 10, right? So we can have a count plot kind of a thing, or a density or a frequency plot also. So this is kind of a univariate analysis in which we're trying to analyze one single variable to the best we can. Okay, so that is my univariate analysis, only a single variable analysis. I'm not trying to do any interactive study here. I'm not trying to club two or three different variables and trying to analyze the data here. So now what is bivariate analysis? So bivariate analysis, as the name suggests, it's an analysis of two variables, right? So we are trying to club two variables here. So these two variables could be anything again. So again, for example, suppose in an Excel file, so and still always, if you're not able to understand anything, just always go back to the base and it says data is an Excel file, okay? Simple as that. So data is an Excel file, for example, okay? Now I have an Excel file. So Excel file, in that we have say 20 columns, right? So what I mean by univariate analysis, so I'll be plotting the graph 20 times for each of my 20 variables. Okay, and now for the bivariate analysis, I'll be having a data for for the two variables I have. So I'll be plotting an interactive study here, right? So I mean, for example, I have 20 columns, right? So now in this first column, one will be plotted against all of my 19 variables. So there'll be what, 20 cross 19 graph available. So if I want to plot a single interactive study, I can still plot 20 cross 19 graphs there, right? So univariate analysis is comparatively easier because we're trying to only analyze one single variable there, right? But for the bivariate analysis, we're trying to analyze the data. We're trying to analyze the cross-sectional study here. We're trying to analyze how the two different variables are interacting with each other. You got it? So that's the bivariate analysis. And again, obviously, even in this is very much clear, right? So there are certain set of graphs which can be used in univariate, and there are certain other set of graphs which can be used in bivariate. I mean, if you want to plot a bivariate graph, you cannot plot a univariate data on top of it, right? So it's pretty much simple. So there are some different set of graphs which can be plot against univariate and against bivariate, right? And also the data types are different. So if the data is a numerical data and the data is a categorical data, and then what is a numerical and categorical? It's very simple. So if the data is a continuous variable like salary, for example, it's a number, right? And then we have something called as say, I mean, there are a lot of things, right? So I mean, if the column is a number, right? So that is a continuous variable, okay? And then if the column is a class like For example, as I said, gender, and then as I said, rating, good, average, bad. So we have certain classes available of that, right? So that is my categorical column, right? So again, so even for univariate and bivariate analysis, we have certain set of graphs available individually, both for my numerical and my categorical data, because I cannot plot the same graph for my numerical and then similar for my categorical, right? So I mean, again, there are some distinctions there as well, right? So we'll go that much in deep for univariate, for numerical and categorical, and likewise for bivariate, numerical and categorical. So we'll see all the interaction studies possible, and we'll see how the different graphs can be plotted, what all different options are available, and how we can use them. Okay, so that's our objective. That's how we'll be doing it. Make sense? Right? Any questions, guys? Anything? So this is actually a brief layout of our data visualization. Okay, the reason I wanted to tell you this theory is because see, again, it's always easier to jump to the graph and show you something and then just keep on talking about it. But again, you need to have the base of why we are doing it. Ultimately, see, the objective is there is no, I mean, the codes are already available, right? So codes are again simple. So there's nothing fancy in the code. Codes are already there. So you can find it on Google also, right? Stack Overflow, wherever you find, you'll get the code. But again, think from a data analyst perspective, think from a data scientist perspective. If your job is to do the data analysis, right? It's not, your job does not end just by running the code, right? Your job actually starts after that, right? Once you've plotted the graph, now the brain of a data analysis comes. Now you have to figure out what this graph is talking about, right? What I'm seeing in this graph, I have to convert that visualization into a business logic, right? Then from that business, I have to find out how can I use this information for my business benefit. So that inference is very important. Okay. So how to read a graph, that is very important. How to get an information out of the graph, that is very important, guys. Okay. So we'll primarily be focusing on that. Okay. And we have planned at least 4 to 5 days on visualization. The reason to that is it is very important to understand, what are the if and buts of my every other thing. Okay. Any questions, anybody? Anybody is having any questions, guys? Guys, any questions? Do let me know that. Okay, great. So that's wonderful. Let's start then. Let's start. Okay. Chalo, plain simple as that. Now, how to get the Seaborn library, right? So it's plain simple. So once you have to install the library, yeah, I mean, obviously Seaborn is a library, right? So you have to install that. Again, installation is very simple. So how are you going to install that? Pip install, as always, as we have been doing this, right? So pip install Seaborn, that's going to install you the latest version for you. And how you can check the Seaborn version? SNS. So I mean, for example, I've imported Seaborn as SNS. So I've given the alias for that library. And then I'm checking the version here, Seaborn SNS dot __ version for me, right? So that's what I'm checking the version. So now again, by default, Seaborn is also it also comes pretty much handy with my certain data sets as well. And what are those data sets? And how to find out which data sets are those, right? For example, here, sns.get dataset names. If you see this, so this is a function which can just list down the data set which is already available within your SNS library. So it comes handy with many of the very interesting data sets. For example, you might have heard of iris data set, right? It is a very common data set which is being analyzed on for any of the data analysis course. If you join any data analysis course, right, online available, they might there is a high probability that they will be analyzing the data on iris. So iris is a very common data set which is used. Likewise, we have Titanic data set. You can see this here. We have Titanic data set. This is a very common data set. And then we have taxis here. And then we have MPG again for the car data set is very, very important. Then we have flights, right? So a lot of things which is available here. Cool. Right, guys, just give me a minute. I'm getting a call. I'm really sorry for this. Hello. बेल बजाइए भैया प्लीज. Sorry guys. Okay. Okay. Great. So that's pretty much about it. So let's start with one of the data sets, right? Okay. So now here, let me show it to you. Here in the pandas data, I mean in Seaborn, right? So we have to also analyze the aesthetics. So what are my aesthetics here? So here the important thing is we can also change the basic layout of my graph. Okay, this is something which is very important. Okay, so now for the layout of my graph here, what we can do is, what all things are important here? Look at this. For example, so I've just plot the very simple graph. I've just written a sign plot function here. I'm plotting a graph. So what I'm done is, so look at this. I'm not doing anything fancy here. So I have called my both Matplotlib as well as Seaborn. So the reason why I did this, because again Matplotlib is used on top. I mean Seaborn is used on top of my Matplotlib, right? So for now I'm trying to show it to you. What will happen if I plot the data using Matplotlib? Okay, so this is my function, this is my data actually. Okay, I'm trying to plot a sine graph, multiple sine graph, and then I'm trying to plot this. So I'm calling this function and then I'm doing plt.show. Plt is what? My Matplotlib. Okay, so can you see this? It is giving me a very a plain simple graph. So here I can see, yes, there are some different colors available, and then I have the graph which is showing me the crest and trough for my sine wave, right? This is being plotted using the Matplotlib. Now, how we can do this using the Seaborn? So what is the advantage? Because now we have seen the differences, right? So it is an extension on top of Matplotlib. It is built on top of Matplotlib, and we have certain advantages there. So what are those advantages? Let's see that, right? This is something which is very important. So now here, important thing is to understand it. We can obviously, with the help of Seaborn, tweak the layout of my graph. We can change the visual appearance of my graph. Okay, and how I can do that? So just look at this. So same graph. Look at the same graph here. Okay, same data. Now instead of doing calling kind of plt.show, I just before calling the plt.show, I just use sb.set. I'm setting the environment here again. So here you can see this. So we are just using the Seaborn defaults instead of Matplotlib defaults. Okay, so we just use set the graph to use the Seaborn defaults instead of Matplotlib defaults. Okay, so we can call this using a set function. Okay, so we just need to call the set function for that. So again, everything remains the same. If you compare the code, right, everything remains the same. It's just like before calling the data, I have just set the environment, set the overall layout as Seaborn graph. Okay, not the Matplotlib graph, but the Seaborn graph. That's the only change I did. And can you see the difference? It was a plain, simple white graph, but here I could see some scaling kind of a thing available here. So I could see some grid in the background, some gray grid, right? Okay. Is the difference visually visible to you? Is it clearly visible, right? So that is what it is making the graph more visible. So now it is very, very appealing. Now we can see this, right? So 2 is coming in this line, and then I have 4 here. Okay, so this point is coming under 4. So now we can actually infer the data quite clearly. But here you have to assume, okay, so my 2 might be coming somewhere here or here, and then 4 might be here. So it's like more difficult to read the graph by using a Matplotlib, right? But with the same Seaborn, it gives you more granularity. And yes, so right now I have just used the basic set function. Okay, so this basic set function is doing nothing at this moment. It's just using the Seaborn defaults, the default functionalities which we have. Okay, we can call any sort of function. We can obviously fine tune this. We can change the background layout. We can change a lot of things. So let me show it to you one by one. Okay, so here the representation of the data is same, but the representation style varies in both, right? So here you can see this. Although the representation of my data is same, but the style varies. So what is my style? Is the look and feel of my data, right? So basically, now what happens is in Seaborn, this splits the Matplotlib parameters into 2 groups. So there are 2 different categories of such changes which are available. Okay. First, which is plot styles, and the second is plot scale. Okay, so first is plot styles and the second is plot scale. We'll talk about both of them one by one. Okay, so what is my plot style? Style means the background here. Okay, so what are my plot style? We can obviously change the style of my, so the style is nothing but my theme here. Okay, so here by default it is dark grid. Okay, so we have in Seaborn we have 5 different themes available. Okay, so by in Seaborn by core we have 5 different themes available. What are those? Dark grid, which is default. So this which you are seeing here, the default one is a dark grid. Okay, it's by default. And then we have white grid, we have dark, we have white, and we have ticks as well. So these are my 5 different themes available in Seaborn. And how you can change the theme here? By using the function set style. Okay, clear guys? Making sense? How you can change the theme of your graph is set style. Again, remember, I have not started plotting any graph till date. It is just a plain simple sine wave for me which I'm plotting. Okay, I'll jump to the code, I'll jump to the graph, don't worry about that, but I'm trying to show it to you how you can change the aesthetics of your graph. And this aesthetics is pretty much valid for all graphs. So whatever graph you plot, right, it is applicable to all of your graph because aesthetic is pretty much available for everything, right? So you have to, aesthetic is valid for all the graphs, right? So that is the reason why you have to understand this part first. So in the style part, we have, so we can change the theme of my graph. And what are my different themes available here? We have dark grid, we have white grid, we have dark, white, and ticks. So we have 5 different themes available, and we can change this using set style function. Okay. Now look at this plain simple thing. Same graph, same everything, same code also. Even this code is very much the same. Okay. Now, did you remember earlier I was using sb.set. Okay. So this was my earlier code, right? sb.set. But now what I did, I just commented this out, sb.set, and rather of using the default, which is a dark grid for me, I just use a function sb.setStyle. Okay, and what is a set style? I use a white grid, which is white grid, another theme for me. In pretty much it, I can also use dark or white or ticks. I can still do any style, but again, within these 5 only, right? So now if I plot this white grid, right? Now look at the data. Look at the graph now. Can you see this? Now the aesthetics, the look and feel of my graph got changed. It's from having a background as dark grid, now it has been changed from dark grid to white grid. Is it making sense, guys? Am I making sense? Just a quick yes or no in the chat. This is something which is important, guys. I hope I'm pretty much clear in these parts. Guys, just to let me know if I'm pretty much clear to everybody and you're able to make sense out of it, or is it going over the board? You're not able to get this. I hope this is pretty much, this is simple. I mean, I'm not doing anything fancy here, right? Yeah, I can show you ticks also. I can show you ticks, pretty much I can show you ticks. So I'll just do ticks here. Oh, my bad. Right. This is your ticks. Pretty much similar to what we have in white grid as well, but I don't see a major difference here. Again, every graph has the same objective, but I could see the fonts are reduced here. So font size are reduced, and then we have the ticks functionality here. But again, so it depends on what kind of use case you have, what kind of problem statements you're trying to solve. So you can obviously check which one is better to your use case, right? So it might not be valid that only dark grid is fine or ticks are fine or dark is fine. So depending on your use case, you can obviously choose the option which you have, and how you can do that using the function set style. Okay. Cool. Okay. Now one thing. Again, we have a very good functionality available under the same, this is again add-on to my set style. We can also use a dspine function. Okay, So now what is d-spine? Okay, so now can you see this? My data ultimately it is an x and a y axis, right? But the graph is being plotted in a rectangular format. So although we have x and y, but we have still these two axes, which is unnecessary. There's no use of this, right? So there's no practical use of these graphs. It's just like it's an enclosing body for my graph, and ultimately we are showing a rectangle. We are seeing a rectangular kind of a graph, right? But we also have an advanced option to remove these top to top axis. So top axis and the right axis, we can remove this by calling just a d-spine function. Okay. So now how does this d-spine works? Let me show you that. Again, same function, everything. What I've just did it. So we in the set style white, for example, sign plot, before calling the show, I just called d-spine function. So can you see this? It is a sequential kind of a process to write the functions. Okay, so we first set the style, we called the data, then we d-spined the graph, and then we made it appear on the screen, right? So it's a sequential. So whenever you write a plotting code, right, it's a sequential process. So you write the functions one by one. So whatever you want to do, whatever add-ons you want to do in this data, you will call it like this. And now can you see this? Eventually, the top axis and the right axis is missing now. So now we have only the x and the y axis where exactly my data is present. Okay, got it? Clear? So this is for my set style. So but again, as I said, in core we have two different things which we can do. So we have plot style, so we can change the style of my graph, and we can change the scale of my graph, right? So in style we saw theme. So in style we can change. So how we can change the styles? We saw themes as one of the ways we can change the styles, right? So that is one thing. Now apart from themes, what all thing we can change? So we can also change the axis style. Okay. So what is my axis style? So for example, even this axis can be changed. Okay. So here we have, if you go to this axis style, right? Again, you could see just by using this axis style function, you can see what all different arguments it can take. Okay. Just look at this, guys. This list is humongous. You can just keep on editing it. For example, we have something called as axis.face color. We can change the face color of my axis. The axis.grid. Then we have axis.label color, xtick.color, ytick.color. We can change the direction also. And then, I mean, like many things are there. So axis.spine.left, we can change this as well. And then, so you can see this, right? So by using this axis.style function, we can even change the axis component. Let me use one of them and show it to you. Okay, so for example, here, look at this. So I have this, in this sb.setStyle, I have used a dark grid component, but again, I am also passing the axis components here, right? So for example, look at this. So I've used axis.axis below. So what is my axis below? We have something called as axis below also, right? This is again a function available. So we have true and false kind of a thing. So by default, it's true. But again, I've just made it false. Okay, so by default, it is true here. You can see this. This is my by default data. But now I have purposefully made it false. So now what it has changed? So can you see this? The axis, now it has made the appearance different. So the difference is earlier, the grid was behind and my graphs was in front on top of the grid, right? But once I made this false, now can you see this? Now the grid is on top and my data is in the back. Can you see the difference? You can see the difference, right? So likewise, we have like n number of such options available even in the set style functionality also. But again, the core function still remains the same. That is set style. Don't forget this, guys. Okay. Set style is my major function to change the look and feel of my graph. Okay. And we can do this. We can change the theme. We can change the axis lookouts also. Like I showed you, there are multiple such options available. Clear, guys? Any questions? Likewise, for example, look at this. So here I added multiple such arguments. I added axis.below false. I changed axis.face color as red. And then I did axis.grid is equal to true. And then I said grid.color is equal to yellow, right? So for example, can you see this? Now all of these things are changed. So I mean, although this graph is not looking nice, but you can see the flexibility which I have to change the appearance of my graph. I change the background color of my grid. I change the grid line ka color also. I have multiple such options to do that. Even I can change the size, font, appearance. I can change hell number of things in this. Okay. complete fine tuning, complete modifications are possible in the style change of my graph. Make sense, guys? Clear? I hope this is pretty much clear, right? Okay, so just to tell you this, for my plot style, okay, for this one, we use the functionality set underscore style. Okay, this is my function which we use to set the style, and in this set style we have what? So we have what all things? So we have themes, and we can change the axis. Cool, we saw that. Now what about plot scale? Okay, Akash says in set style how many parameters? Yes, very good question. So again, yes. So here the second parameter is optional, as I said. So axis parameter is optional. So in axis we can provide as many things as we can, but again that is an optional parameter. It's not mandatory that I have to provide the axis only for me. Okay, but it's an optional parameter. Cool. Okay, great. So now we are pretty much done with my first set of changes, which is my theme. Okay, set style is pretty much done. Now about the scaling part. So as I said, we can change the scale also, right? So scale means this x and the y axis ka values, how I can alter the values of these things. Even this is pretty much possible, right? So any idea, guys? What do I mean by this? What do you mean by scale? Can somebody tell me what do you mean by scale? So what do you mean? I mean, what will change if I change the scale? What does it mean? Any suggestions, guys? Any idea on this? Guys, quickly, any suggestions on what do you mean by scales here? Anything is coming to your mind? What do you mean by scales? See, again, eventually what do you mean by scale is, so we are changing the axis ka range of my data, right? So how exactly these values are being popped up. So in the scaling part, we do it using the function set context. Okay, so only two functions you have to keep in mind: set style for changing my themes, for changing my overall lookout and feel of my data. And the second is set context. For the set context, what we do, we change the the kind of axis scaling of my data. So here the options have paper, we have notebook, we have talk, and we have poster. So there are 4 different options available. Okay, so again, by default is notebook. And notebook, so basically whatever you are seeing, this scaling technique, right? This is called as notebook technique. Okay, let me show it to you how the changes would look like if we, so for example here, now I'm using both the things, set style and set context, right? So in the set style, we've already seen this. So we are changing the dark grid and axis is below, that's fine. Now also we are calling sns.context. Okay, sns.context. So as you know, by default is notebook, but now we are making it poster, right? So we are making it poster. So what does poster mean here? Okay, so poster means, look at this, the same data which was earlier in a very smaller font. The range is from -6 to 6, so all the individual numbers at the interval of 2 is coming up. Now in this, the range is showing -5 to 5, more bold. I mean, I would say that more visually clear, right? Can you see this? This is poster for you. We have changed the scaling appearance also. Making sense? And likewise, the grid also got changed. And we can call paper also. For example, if I do paper, you can see this. What is this? SNS is not defined. By import Seaborn as SNS. Okay. So now can you see this? This is my paper look. And then I can also do my talk. We have more granular, so 2.5, -2.5, and all this coming. We can do poster, more granular. So if we call poster, can you see this? So this is how you change the look and feel of your data, guys. Okay, so ultimately, see what all things we did here. So we talked about, we'll talk about colors maybe tomorrow. So let's not rush into things. Okay. So ultimately, we did two things today. So we did set style and set context. So set style, I'll just write down the things here. So just give me a minute. So we did two things today. Okay. We saw how to change the aesthetics of graph. Okay, correct. The first thing which we saw, we can change the we can change the style. Okay, style, in the style we have multiple options, such as we can change the theme, we can change the axis options, and all of these is happening using what function we have called as set underscore style. Cool. And we have an optional argument also for dspine. We saw that, correct? Now on top of this, we have second more a way, which is change the scale. Correct? We can change the scale as well. And this change the scale can be done using set underscore context. Cool. This set under context. And this set under context, what we're doing is we have I think four options available to change the layout. Plain simple, and I've shown you the examples also given. So examples, we saw examples also. Is this point clear to everybody? So this is what we have studied today. Is this point clear, guys? Are you comfortable in plotting the graph, changing all the things regarding your axis, your spines, your all the other functionalities, changing the aesthetics of my graph? I hope this point is pretty much clear to everybody, right? What is not sure? Akash, I didn't get that. So Vasanta also, she says graph will change. Okay, so graph will change. Yes, so even the graph, so once we change, no, graph content value is not getting changed. See this. Again, don't see, again, see if this peak is at 6, right? So if it is 5, there's somewhere around 6, right? The content is not changing. Even right now it is at 6 only, right? But now since we have changed the scale, right? The lookout of the graph will change. The values are not changing. Values are still the same only. It's just like once we have changed the scale of my axes, right, the graph feel would change. You got it? Clear. Okay, great. So with this, guys, let's take a pause for today. Okay, let's take a pause. I think we have done quite a good understanding today. And then maybe we can meet tomorrow again, but again we'll be meeting at 10 p.m. So that's only for today. It was 10 a.m. but tomorrow onwards, again at the same time, we'll be meeting at 10 p.m. only. And tomorrow we'll start with the color palettes. I'll show you what all different color options are there. So you can see the by default color options, right? So red, blue, green, and the orange and coming up. So we can change these colors also. And there are multiple such color options are there. Okay, I'll show you how you can change the colors on such different graphs. So again, we're still talking about individual topics. We've still not jumped into the actual graph. Okay, so we're still into the boundary of my graph. We're trying to see how we can change the layout, the colors, the feel. Okay, and then once this part is clear, right? Again, plotting will become easier for you. You can obviously play around in the graph. You got it? You can make the graph more appealing. So depending on that. Cool, guys. Thank you so much with this. Thank you so much for joining in the early morning today on a weekend. I understand it's slightly trickier. So, but again, thank you so much for being with me. So we'll again see you tomorrow, tomorrow evening, 10 p.m. same time as always. And then we'll be starting with the color palettes for the Seaborn.